Welcome to Marikamba PU College, Sirsi, Department of Physics.
Today we study regarding capacitors and capacitances. Now what is a capacitor? Now capacitor, it is a device having two conductors separated by an insulating medium. Now this device stores charges and hence the electrical energy. The two conductors, if I write a one conductor like this and here is another conductor. Now one conductor is positively charged if I say, and another conductor is negatively charged. Now they are separated by a certain distance. That system constitutes a capacitors. The charge on the first conductor is Q1, charge on the second conductor is Q2. Or Q1 is, since here the charges are positive, I will take it as plus Q. Now in this conductor charges are negative, therefore I will take this as minus Q. Now these two conductors are maintained at a potential of, now first conductor is maintained at a potential of V1 and the second conductor is maintained at a potential of V2. Therefore the potential difference between the two conductors is V is equal to V1 minus V2. Therefore capacitor is a system of two conductors separated by a dielectric or an insulating medium which stores electric charges and hence electrical energy. Now the electric field in the region here is directly proportional to the charge it is containing. We are already familiar with this one. Electric field is directly proportional to the charge. As the charge goes on increases, what about the electric field? Obviously it also increases. If I double the charge, what will be the electric field? Electric field is also doubled. If I reduce this to half Q by 2, what will be the electric field? Obviously electric field is also is equal to Q by 2 because in the case of an infinite sheet we have electric field is equal to sigma by epsilon naught, or that is equal to Q divided by epsilon naught into A. So area is area of cross section, epsilon naught is a constant, therefore electric field is directly proportional to the charge. So as the charge increases, the field increases. Charge decreases, the field also decreases. And also we are familiar with the relation between the electric field and the electrostatic potential. That is, electric field is equal to minus of delta V by delta L, that we have already derived, or simply we can say electric field also proportional to the potential. So that is the meaning, the potential is also directly proportional to the charge. As the charge increases, the potential also increases. As the charge decreases, potential also decreases. It is a very interesting property. So therefore the charge is directly proportional to the potential, and we have the ratio of these two is always a constant, because as the charge increases, potential also increases. Charge decreases, potential also decreases. Therefore the ratio of charge by potential, the ratio of charge by potential is a constant, and that constant we call it as capacitance. The ratio of charge to the potential is always a constant quantity, and that constant physical quantity here we call it as capacitance. ಅದನ್ನು ನಾವು capacitance ಅಂತಂದೇಳಿ ನಾವು ಅದನ್ನ ಕರಿತೀವಿ. Now therefore charge is equal to C into V, or the other relations V is equal to, so Q by C, like that we can write in different formats. Now capacitance, it is the ratio of charge to the potential. It is a constant quantity. Look here, as charge increases, potential also increases. As charge decreases, potential also decreases, so that the ratio is always a constant quantity. and hence here the capacitance does not depend on the charge or the potential, it only depends on the geometrical configuration, that is shape, size and area, like this. It only depends on the geometrical configuration of a conductor. That means a capacitor means it is having two conductors. Can you have a single conductor which can work as a capacitor? Yes. If you consider a single conductor, it is charged somewhere. Whether it behaves as a capacitor? Yes. Because we need another conductor. We assume that the another conductor is placed at infinity. So that a single conductor, it also acts as a capacitor. Therefore, capacitance depends on geometrical configuration, that is shape, size and distance between or separation between the two conductors. Now, what is the SI unit of capacitance? It is farad. We denote it by F. Therefore, 1 farad is equal to it is 1 coulomb per volts. It is 1 coulomb per volts, that is 1 farad that we write. Okay. Now here, look here. Now capacitance directly depends on the charge. Now I want to have a larger capacitance. Then obviously the potential and hence the electric field in the region, it should be smaller and smaller. Now what will happen if I increase the electric field? As the electric field is increased in this region, now that electric field, it ionizes the air present in the gap. Now those ions, in the presence of the stronger electric field, they move towards the opposite conductors. A positive ion moves towards the second conductor, which is negatively charged, and a negative ion, it moves towards the first conductor, that is positively charged, and that neutralizes the charges and hence it decreases the capacitance value. That is one case. Now that means there is a limit for the electric field and the potential. Now that limit is called the another concept of dielectric strength. The maximum electric field that a dielectric can withstand without any breakdown or without any reducing the insulating property is called dielectric strength. For air, the dielectric strength is 3 into 10 to the power of 6 volt per meter. Now if we have a conductor, two conductors separated by a distance of 1 centimeter, then the dielectric strength, if the space between those two conductors is an air medium, then the dielectric strength becomes 10 to the power of 4 volt per centimeter. Now this is in terms of meter and this is in terms of centimeter. So therefore we can get a larger capacitance value by decreasing the potential. Potential ಅನ್ನು ಕಡಿಮೆ ಮಾಡೋದ್ರಿಂದಲೂ ಸಹ ನಮಗೆ larger capacitance ಬರ್ತಾ ಹೋಗ್ತದೆ, so that we can store larger charges at a smaller potential. Now this is important, that is the dielectric strength. The unit farad becomes a larger one, therefore we use its submultiples of this unit, that is microfarad. 1 microfarad means it is 10 to the power of minus 6 farad. Nanofarad, that is equal to 10 to the power of minus 9 farad, or picofarad, that is 10 to the power of minus 12 farad. Now study a parallel plate capacitor. Now a capacitor having two conductors which are parallel in shape as shown in the diagram. Now here we are having two conductors. They are parallel rectangular plates separated by a distance, small distance d. The area of each conductor is A. Now this system constitutes a parallel plate capacitor. Based on the shape of the two plates, we call it as a parallel plate capacitor. Now we have to obtain an expression for capacitance of a parallel plate capacitor. For that one, we have considered two rectangular parallel plates of area of cross section A and separated by a small distance D. Now the first plate is positively charged and the second plate is negatively charged. The charge density of the first plate is plus sigma and the charge density, surface charge density of the second plate is minus sigma. In order to obtain the expression for capacitance of a parallel plate, we consider three regions. One is first region, now this is the second region, and third region is between the two plates. Now look here in the region 1, what is the expression for electric field? For that one, we are already familiar in the case of expression for electric field due to an infinitely long thin sheet which is uniformly charged. That expression we are already familiar, that is sigma divided by 2 epsilon naught. Electric field due to an infinitely long thin sheet which is uniformly charged is sigma is equal to sigma by 2 epsilon naught. ಆ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಅನ್ನ ನಾವಿಲ್ಲಿ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ವಾಟ್ ಈಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇನ್ ದ ಫಸ್ಟ್ ರೀಜನ್ ಅಂಡ್ ಸೆಕೆಂಡ್ ರೀಜನ್ ಅಂಡ್ ಇನ್ ದ ಥರ್ಡ್ ರೀಜನ್ ಅದನ್ನು ನಾವು ವರ್ಕೌಟ್ ಮಾಡುವ. ನಾವು ಲೆಟ್ ಮಿ ಟೇಕ್ ದ ಫಸ್ಟ್ ರೀಜನ್. ನಾವು ಫಸ್ಟ್ ರೀಜನ್ ಅಲ್ಲಿ ಯಾವುದೇ ಒಂದು ಪಾಯಿಂಟ್ ತಗೊಂಡು ವಾಟ್ ಈಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ದ ಫಸ್ಟ್ ಪ್ಲೇಟ್ ಅಂಡ್ ವಾಟ್ ಈಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ದ ಸೆಕೆಂಡ್ ಪ್ಲೇಟ್ ಅನ್ನೋದನ್ನು ವರ್ಕೌಟ್ ಮಾಡುವ. ಇಲ್ಲಿ ವರ್ಕೌಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಒಂದು ಅಸಂಪ್ಷನ್ ಏನು ಅಂತ ಹೇಳಿದ್ರೆ ದಿಸ್ ಡಿಸ್ಟೆನ್ಸ್ ಡಿ ಈಸ್ ವೆರಿ ಸ್ಮಾಲ್. ಎಷ್ಟು ಸ್ಮಾಲ್ ಅಂತ ಹೇಳಿದ್ರೆ the potential electric field at any point in this region due to the first conductor and due to the second conductor is almost same in magnitude. Magnitude alli same irtade anta ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ರೆ, if I take any point in this region, now due to the first conductor the electric field, since it is positively charged, it is upwards. Due to the second conductor at that point the electric field is downwards. Okay, that you should remember. So therefore the electric field, total electric field at the region 1, at any point in the region 1 is equal to, due to the first conductor it is sigma divided by 2 epsilon naught upper conductor, and due to the lower conductor it is minus sigma divided by 2 epsilon naught. We are already familiar with in this expression. It depends only the surface charge density and the constant epsilon naught. So therefore the total electric field in the first region is 0. Clear? Now let me take any point in the second region. Ee region alli yavadaro one point annu tagondo electric field ge ಏನು expression ಬರ್ತದೆ? Now in the second region also we get the same expression. ನೋಡ್ಕೊಳ್ಳಿ, ಇಲ್ಲಿ second region ಅಲ್ಲಿ ಇಲ್ಲಿ ಯಾವ್ದಾದ್ರು ಒಂದು ಪಾಯಿಂಟ್ ಅನ್ನು ನಾನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ರೆ, due to the positive charge the field is downwards, that is moving away. Due to the negative charge density plate the field is upwards. They are equal and opposite, therefore net field becomes 0. Sigma divided by minus 2 epsilon naught, that is equal to 0. So therefore the electric field outside the plate system is 0. Now we will consider the third reason. What is the electric field inside? Now here this one is positively charged and the lower plate is negatively charged. Therefore the field direction is as shown by the blue lines. The electric field is from the upper plate to the lower plate as shown by the dotted blue lines. Now consider any point in the third reason. If I take any point here, now what is the field due to the first plate? It is downwards. Electric field is downwards. What is field due to the second plate? It is also downwards. Both are in the same direction. Now here it is positive charge radially outward. Now it is negatively charged, therefore radially inward. Therefore the two fields are in the same direction. It is different compared to that of first region and the third region. Remember carefully. So therefore the net electric field in any point inside the third region is equal to, so first one is sigma divided by 2 epsilon naught, so minus of minus it becomes sigma divided by 2 epsilon naught, so that is equal to 2 into sigma divided by 2 epsilon naught. So that is equal to sigma by epsilon naught. So minus of minus, it becomes plus. So it is minus of minus. Minus of minus becomes plus. That you should remember. Therefore, the total electric field between the two plates, in the space between the two plates is equal to sigma divided by epsilon naught. But what is sigma? Surface charge density, that is given by charge divided by area of the plate, any one of the plate ಅಂತ ಕರಿತೀವಿ. Okay. Now, since this electric field is constant inside, therefore the electric field is localized. The meaning is the electric field between the two parallel plates is always uniform. Since the electric field is uniform, there exists a potential. That potential is given by the relation in terms of electric field. So that is E into the distance of separation. Now this relation we obtained from the previous derivation, that is electric field is equal to negative of potential gradient that we have derived. Based on that concept, we have written the potential V is equal to E into D. Therefore, E is this one, that is Q into D divided by epsilon naught into A. That we have obtained. Now, what is our aim? Our aim is to obtain the expression for capacitance. Now, what is the definition for the capacitance? Now, capacitance is equal to charge per. Now, from this relation, carefully look here. What is charge? Charge is Q here. Now, cross multiplying. Now, here what we will get? Now, you will cross multiply here. Epsilon naught A comes here, and V goes here, and D comes here in the denominator. Is equal to this one is Q by V. So therefore, what we will get? Capacitance C is equal to Q by V. If I substitute here, I will get is epsilon naught A by D. Therefore, capacitance is equal to epsilon naught A divided by D value. Now, carefully look here the expression for the capacitance. It only depends on the three quantity here. Now, epsilon naught, it is obviously a constant. It only depends on the area of cross section of each plate A and is inversely proportional to the distance of separation. So ಅಲ್ಲಿಗೆ ನಾವು ಕೆಪಾಸಿಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ಎರಡು ರೀತಿ ಮಾಡಬಹುದು. ಏರಿಯಾ ಜಾಸ್ತಿ ಮಾಡೋದ್ರಿಂದಲೂ ಕೆಪಾಸಿಟೆನ್ಸ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಇನ್ನೊಂದು ರೀತಿಯಲ್ಲಿ ಎರಡು ಪ್ಲೇಟ್ ನ ನಡುವೆ ಇರತಕ್ಕಂಥ ಸೆಪರೇಷನ್ ಅನ್ನ ನಾನು ಕಡಿಮೆ ಮಾಡ್ತಾ ಬಂದ್ರೆ ಆಟೋಮೆಟಿಕಲಿ ಕೆಪಾಸಿಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗ್ತದೆ. Now, epsilon naught value ನಮಗೆ ಗೊತ್ತುಂಟು 8.54 into 10 to the power of minus 12. If A is equal to 1 meter square ಅಂತ ನಾವು ತಗೊಂಡ್ರೆ and distance of separation ಅನ್ನ 1 millimeter ಅಂತ ಹೇಳಿ ತಗೊಂಡ್ರೆ that is 10 to the power of minus 3. If I work out this one, I will get it is 8.854 into 10 to the power of 9 farad. Under 1 meter square, A is equal to 1 meter square. A is equal to 1 meter square, and the distance of separation 1 millimeter, 1 meter square. Andre 1 meter length, 1 meter breadth irtakanta ಎರಡು ಪ್ಲೇಟ್ ಅನ್ನ just 1 millimeter distance ಅಲ್ಲಿ ಇಟ್ರೆ ಅದರ ಕೆಪಾಸಿಟೆನ್ಸ್ ಎಷ್ಟಾಗ್ತದೆ? 8.854 into 10 to the power of minus 9 farad ಆಗ್ತದೆ ಹೇಳಿ. ಹಾಗಾದ್ರೆ ಎರಡು ಪ್ಯಾರಲಲ್ ಪ್ಲೇಟ್ ಕೆಪಾಸಿಟೆನ್ಸ್ ನ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಕೆಪಾಸಿಟೆನ್ಸ್ 1 ಫ್ಯಾರೆಡ್ ಆಗ್ಬೇಕಾದ್ರೆ ಏನು ಅನ್ನೋದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡುವ. ಇಫ್ ಕೆಪಾಸಿಟೆನ್ಸ್ ಈಸ್ ಟು ಬಿ 1 ಫ್ಯಾರೆಡ್ ಅಂಡ್ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಸೆಪರೇಷನ್ ಈಸ್ 1 mm, 1 millimeter ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಸೆಪರೇಷನ್ ಆಗಬೇಕಾದ್ರೆ ನಾವು ವಾಟ್ ಈಸ್ ದ ಏರಿಯಾ ಆಫ್ ಈಚ್ ಪ್ಲೇಟ್ ಅನ್ನೋದನ್ನ ಜಸ್ಟ್ ಬೈ ಯೂಸಿಂಗ್ ದಿಸ್ ಫಾರ್ಮುಲಾ ನಾವು ವರ್ಕೌಟ್ ಮಾಡಿದ್ರೆ ನಾವು ಏರಿಯಾ ಈಸ್ ಈಕ್ವಲ್ ಟು ವೆರಿ ಸಿಂಪಲ್ C into D divided by epsilon naught. Now capacitance is 1 and the distance is 1 into 10 to the power of minus 3 divided by 8.854 into 10 to the power of minus 12. So the numerator ಮಾಡಿ simplification ಮಾಡ್ಕೊಂಡ್ರೆ roughly we will get 10 to the power of plus 9 meter square. 10 to the power of plus 9 meter square. So ಅದರ ಅರ್ಥ ಇಷ್ಟೇಯ ಅದನ್ನ ನಾವು ಲೆಂತ್ ಮತ್ತೆ ಬ್ರೆಡ್ತ್ ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ ಸೊ ದಟ್ ಕಮ್ಸ್ ಅರೌಂಡ್ ಎ ಪ್ಲೇಟ್ ಆಫ್ ಲೆಂತ್ 30 kilometer and breadth 30 kilometer. So ಅಲ್ಲಿಗೆ ಒಂದು ಪ್ಯಾರಲಲ್ ಪ್ಲೇಟ್ ಕೆಪಾಸಿಟರ್ ನ ಕೆಪಾಸಿಟೆನ್ಸ್ 1 ಫ್ಯಾರೆಡ್ ಆಗಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ 30 ಕಿಲೋಮೀಟರ್ ಉದ್ದ 30 ಕಿಲೋಮೀಟರ್ ಅಗಲ ಇರತಕ್ಕಂತಹ ಎರಡು ಪ್ಲೇಟ್ ಅನ್ನ ತಗೊಂಡು ಅವೆರಡು ಪ್ಲೇಟ್ ಅನ್ನ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಇಡಬೇಕು ನಾನು? ಸೊ ಜಸ್ಟ್ 1 mm ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಇಟ್ರೆ ನಾವು ದಟ್ ಸಿಸ್ಟಮ್ ಹ್ಯಾಸ್ ಎ ಕೆಪಾಸಿಟೆನ್ಸ್ ಆಫ್ 1 farad. So therefore 1 farad is a very large number. So here we have assumed that while deriving the area, the space between the two plates is an air or vacuum. It contains an air or vacuum ಅಂತಂದ್ರೆ ನಾವು ಅದನ್ನ ಹೇಳಿದ್ದೇವೆ. Vacuum ಅಲ್ಲದೆ ಬೇರೆ ಯಾವುದಾದರೂ ಮೀಡಿಯಂ ಅನ್ನ ಇಟ್ರೆ ಏನಾಗ್ತದೆ? That is, if I introduce a dielectric in the space between the two capacitors, now what is the effective capacitance? That we will study in the later section. Now we will work out what is the effect of dielectric on a capacitance. Now we will have a parallel plate capacitor. Area of cross section capital A. The distance of separation is small letter d. The surface charge density is sigma. Okay. Now, if initially there is air present here, ಎರಡು ಪ್ಲೇಟ್ ನಡುವೆ ಏರ್ ಇದೆ ಅಂತ ಹೇಳಕೊಂಡ್ರೆ ನಾವು ಆಲ್ರೆಡಿ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಇದೆ. The expression for capacitance is C is equal to epsilon naught A by D ಅಂತ ಗೊತ್ತುಂಟು. Since we have taken air, I will take the capacitance is C naught. So C naught is equal to epsilon naught A by D ಅಂತಂದೇಳಿ ನಾನು ಅದನ್ನ ಕರಿತಾ ಇದ್ದೀನಿ. Now I am placing a dielectric medium. ಒಂದು dielectric medium ಅನ್ನ ಇಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. I am placing a dielectric medium here. It is covering the entire space between the two plates. It is a dielectric medium of dielectric constant, some constant K ಅಂತ ಹೇಳಿ ಕರೆಯುವ. ಅದನ್ನ ನಾನು ಪ್ಲೇಸ್ ಮಾಡಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಕೆಪಾಸಿಟೆನ್ಸ್ ಮೇಲೆ ಏನಾದರೂ ಎಫೆಕ್ಟ್ ಮಾಡ್ತದ ಅನ್ನೋದನ್ನ ನಾವು will work out. Now, because of the presence of the electric field decreases by a factor given by sigma minus sigma p divided by epsilon naught. Sigma is surface charge density in the absence of dielectric. Sigma p surface charge density on the outer face of the dielectric. So therefore sigma minus sigma p corresponds to net surface charge density. Therefore electric field obviously reduces. Since the electric field reduces, what about the potential? The potential also has to reduce. It is E into D. So that is given by sigma minus sigma p divided by epsilon naught into D. For linear isotropic dielectric, we can assume that sigma minus sigma p is proportional to sigma. Now this is net charge, the net surface charge density, that is proportional to the charge density in the absence of dielectric. Or we can write this one as sigma minus sigma p is equal to sigma divided by k. Obviously ನೋಡಿ ಇಲ್ಲೂ ಸಿಗ್ಮಾ ಇಲ್ಲಿ ಸಿಗ್ಮಾ ಸೇಮ್ ಇದಾನೆ. ಸಿಗ್ಮಾ ಮೈನಸ್ ಸಿಗ್ಮಾ ಪಿ ಅಂತ ಹೇಳಿದ್ರೆ ಇವನು ಕಡಿಮೆ ಆಗ್ತಾನೆ, ಇವನು ಜಾಸ್ತಿ ಆಗ್ತಾನೆ. ಸೊ sigma minus sigma p is proportional to sigma, or we can write where k is the characteristics of the dielectric, sigma by k ಅಂತಂದೇಳಿ ನಾನು ಬರ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ. Now that I substitute here, now V is equal to sigma minus sigma p, that is sigma by k, d by epsilon naught. It is d divided by epsilon naught. We know that what is sigma? Charge per unit area. If I substitute that one, so q d divided by epsilon naught k a ಬರ್ತದೆ. Now what is the definition for capacitance? Now here initially I have taken C naught. Capacitance in the absence of dielectric, or capacitance in vacuum, air or vacuum. Now the capacitance in the presence of dielectric is, it is the ratio of charge by volume if I rearrange the terms here, I will get it is epsilon naught K A divided by D. So therefore, what is epsilon naught A by D? It is the capacitance in the absence of dielectric. Therefore, this one is equal to K into epsilon naught ಅಂತ ಆಗ್ತದೆ. So therefore, the capacitance in the presence of dielectric is going to increase by a factor K, and this is called dielectric constant. By this relation, we can define the dielectric constant. It is the ratio of capacitance in the presence of dielectric to the capacitance of the parallel plate with air or vacuum. Now, the product here, epsilon naught into K, is denoted by the letter epsilon. That is called permittivity of the dielectric or the medium, or the dielectric constant K is equal to, so it is epsilon divided by epsilon naught. Here K is also called as relative permittivity of the medium, that is equal to epsilon divided by epsilon naught. So therefore K is the dielectric constant.